Irrational numbers. Well, this is the first time that we've gotten to a category that doesn't include the previous one. Rational numbers are all the numbers that can be written as a fraction, and in decimal form they either repeat or terminate. So to be an irrational number, that's all the rest of them. Ones that cannot be written as a quotient or cannot be written as a decimal that terminates or repeats. Some of the examples of irrational numbers that occur in nature, I mean, believe me, we didn't want to make these up. These are natural. The ratio of a circle's circumference to its diameter, pi. 3.14159. These numbers go on forever and ever and never repeat. Another one is the hypotenuse of a right triangle with legs of length 1. Square root of 2. 1.414, and again it keeps going on forever and never repeats. Most of your roots, if you're taking the square root of a number that's not a perfect square, they're going to be irrational numbers. Square root of 5, square root of 7, square root of 8. Those are all irrational because they're not the square root of a perfect square. Things like the square root of 4, since the square root of 4 is 2, that is a rational number. Rules of exponents. Let me take you back a step because there's something that's missing in your notes, and that's in your notes that's missing in my presentation. That's the real numbers. Altogether, the rational numbers and the irrational numbers make up the real numbers. The real numbers are any number for which we know something larger and something smaller. Another way of saying that is a real number is any number that can be written on a number line. For example, -1 is a real number because we know that -2 is smaller than it and 0 is larger. Pi is a real number because we know it is bigger than 3 and smaller than 4. The square root of 2 is a real number because we know it's bigger than 1, smaller than 2. Basically, the real numbers are going to include everything except infinity and negative infinity, because those are numbers those are ideas. Those aren't numbers we can actually reach. And the square root of a negative number. Those are the only things that are not real numbers, and so any other number you see will be a real number. Going back now. Rules of exponents. Talking about exponents, we have to be real careful when we're looking at them. In the expression a to the s power, a is the base and s is the exponent. A to the s indicates that we're going to have the factor a s times. There are s factors of a. So 2 to the 5th means we're going to have 5 factors of 2. 1, 2, 3, 4, 5. Notice the 5 is not getting multiplied by anything. The 5 is a counter for us. It counts how many of these 2's are being multiplied. When you're looking at these, it's very important to understand what the base is. The base is the number or the variable immediately in front of the exponent. For example, -3 to the 5th power. We have to be careful with this because the base in this case is the 3. It's the thing right in front of the 5. The thing right in front of the 5 is the 3. For xy squared, the base is not xy, it's just the y, just the thing immediately in front of the squared. If we had wanted, because sometimes we want it to have a base of -3, or sometimes we want to have a base of xy, if we had wanted that, we would have needed to use parentheses. -3, the quantity raised to the 5th. The thing right in front of the 5 is all the stuff in parentheses. That's how we get -3 as the base. xy, the quantity squared, the thing right in front of the 2 is all this stuff in the parentheses. That's how we get all of that included as the base. Looking at our rules, we have the product rule. If you have base to a power times a base to a power, that is the base to the sum of the powers. So if we have 3 to the 5th times 3 to the 3rd, that's going to be 3 to the 5 plus 3, which is 3 to the 8th. Or if we have 2 to the 6th times 2 to the 4th, we have the same base. 6 plus 4 is 10. Quotient rule. Again, quotients are very closely related to products. So we're going to do the similar relationship, except this time it's subtraction. If you have a base to a power divided by that same base to a power, it's going to be the base to the difference of the two powers. So 3 to the 5th over 3 to the 3rd is going to be 3 to the 5 minus 3, which is 3 squared. Or x to the 15th over x to the 10th is going to be x to the 15 minus 10 is 5. 0 and negative exponent rules. A to the 0 is 1, as long as a is not 0. This is a time when it's real important to notice what your base is. A to the 0 is 1, so anything to the 0 power is 1. A to a negative exponent is the reciprocal of a to that power. And it looks like we fell off the edge here a little. 1 over a to a negative exponent is going to be a to the positive power. And again, that's as long as a is not 0. So, since anything to the 0 power is 1, 5 to the 0 power is 1. Negative 3x, all raised to the 0 power. The 0 is acting on everything in parentheses, so all of this stuff is going to become 1. We do need to be careful. Negative 3x to the 0, in this case, the 0 is only acting on the x. So x to the 0 becomes a 1, but the negative 3 just goes along for the ride. So it does matter what your base is. It's real important to make sure you know what you're doing. Looking at these negative exponents, 3 to the negative 4th would be the reciprocal of 3 to the positive 4. So if you're asked to write this with non-negative exponents, you would write it as 3 to the 4th, or because this isn't very hard to multiply out, 3 times 3 times 3 times 3 is 81. Looking at this one, 1 over x squared y to the negative 3. We have this negative. Remember, it is only working on the y. So the y is the only thing that's going to get taken to the top. It's going to give us y cubed over x squared. Power rule. It's when we have a power, a to the r, all raised to another power. In that case, we're going to multiply the two exponents. So 5 squared to the 3rd is going to be 5 to the 2 times 3, or 5 to the 6th. Okay, this one's a little more interesting. X cubed y to the fourth, there is a distribution that we can do. So this is going to be x cubed to the fourth times y to the fourth. X cubed to the fourth, we'll multiply the 3 times the 4 to get 12. And this is just y to the first to the fourth, that's just y to the fourth. So we get x to the 12th to the fourth.